welcome to the course Introduction to the Psychology of Language. I am Dr. Erp from IIT Kanpur, and we are in the 4th week of the course. We have talked about quite a few things in this course already, starting from where language came from, language evolution. We've talked about a little bit about speech. We've talked a little about how children acquire language. Now it is our turn to move into how people negotiate different aspects of language, different levels of analysis of language, and so on. So what I am trying to do here is, and also going by the organization in the book we are referring for this course, that is Traxler's book, we will go in a sense that we will do a chapter on word processing, then we will probably do something with reading, and sentence processing. We've also already done something about speech processing, that is. So this week is going to be focused on word processing. It will be focused on understanding how people negotiate, interact and use words. How do we understand when words are used around us, and what do we mean by these words that we pick up? Now if you see, for the most part, for at least a naive person, a word is the smallest meaningful unit of the language, and what we will do in this week is to try and understand how really meaning comes about to be attached to this unit. Okay. We will talk about some other levels of analysis as to how people look at words and how do they attach meaning to those words, how is meaning organized in our mental framework, say for example in the semantic store, and we will also talk about, say for example, when a word has more than one meaning, what kind of consequences does it take. We will also spend a little bit of time talking about say for example, how does the brain organize these words and meanings in itself. So we will cover a range of these topics in the 5 lectures in this week. Today we will start talking a little bit about words themselves. So let us begin. We are going to talk about word meaning in today's lecture. Now if you look at, this is a dictionary entry, it's a figure I have picked up out of Google. It's basically kind of telling us a little bit about what a dictionary entry of the word suggests us. And you look at, there are almost 7-8 definitions, 10 definitions I see that are here, which kind of describe what a word is in different ways. So you can say for example, begin with the simplest definition that says it's a sound or a combination of sounds, or its representation in print or in speech that symbolizes and communicates a meaning and may consist of a single or a combination of morphemes. So we will talk about what morphemes are when we move ahead. Okay. Also, say for example, there are particular kinds of uses of the word. Say for example, you want to say I want to have a word with you, I want to have a small conversation with you. Or say for example, things like there was no word in the room or something like that. So there is a pin drop silence in the word. There are quite a few, you have my word, you have my promise that this will happen. So you can already see that the word or any other word for that matter is used in a variety of ways, can mean a variety of things depending upon who is using them in what context. So how do we really do it? How do we really kind of it seems slightly complicated to me if I look at it now, is that say for example there is one word, it might mean this here, but it might mean something else there, and it might mean something completely different in a different circumstance. For me, in order to acquire and remember what this word would mean becomes very complicated, because a word could mean 3 things, or a word just does not mean this, but it means so many other things as well, and it carries and activates so much other kind of information as well. So this is something that we will try and get a grip of in this week and in different lectures during the week. If I ask you what does a word do, and you will see, basically tell me that words basically have this function of describing the world to us. So for example, this is a pen. As soon as I say a pen, you kind of in that PEN get an idea of many things. You have a prototypical image of a pen in your head. You know that a pen is used for writing, therefore that it should have some kind of ink, some kind of a nib, stylus kind of thing there, and it is, say for example, should be slightly longish cylindrical object that affords me a grip to use it in a particular way. All of that knowledge you will get just when I say this is a pen. So the word pen per se includes so much of this knowledge, it includes so much of these things, all of that you can instantiate just by mentioning this word pen. The other thing is, sometimes we come across people saying, I cannot describe this feeling in words, I cannot describe what I saw in words, or I have no words to express. And this is interesting because that is exactly what words are meant to do. If you look at it more closely, isn't this what words do? Say for example, you look at some of these objects here. This is a cartoon by John Atkinson in his blog Wrong Hands, and I have picked it out out of Google for this a little bit of a demonstration. So, if you really look at things here, you can look at a comb, and a comb is actually a follicle distribution system. So, one word comb kind of embeds in itself all of these three words. It could also, as I said, in itself also contain information about the form and everything. Enter to so many different kinds of information. You see the eraser. So, eraser is referred to as a misapplication elimination device or misapplication deletion device. Okay, and then you look at a box and it is called a cubic containment system. So, this is what words are supposed to do. So, what do words do? Words describe our world to us. Words describe what you see around, and that by using words you are kind of capturing that entire set of concepts and communicating them in as many small number of sounds, or say for example as words to the other person. This is what words are supposed to do. And this is interesting, that how is it that so much of information can get packed into one little combination of sounds at once. This is what we will be talking about in some detail. So, if you remember our definition of language, we talked about language as a system of symbols and rules. We are in this week going to talk about these symbols. Okay. Symbols, obviously what are symbols? Symbols are basically things that refer to something else and they do not have a meaning of their own. In class 7th, 8th or in elementary mathematics, once you start doing algebra, the first thing is that x is equals to 2. X per se does not have a value of its own. As soon as you assign it something, a value, it has a value. So, a symbol is also something that it does not really have a value of its own. You assign the value to the symbol and the symbol kind of keeps that value unless you assign a different value to it. There are many examples that you can say. For example, this particular sound combination of sounds, say for example cat, does not have anything in itself to be called, to be representing cat. We had this concept of arbitrariness when we were talking about Hockett's design features of language. So, cat per se, tomorrow if what the word cat is made to mean dog, and enough people start using the word cat to refer to a dog, the symbol will also change its meaning automatically. Then people will start, say for example referring to this as dog. There are so many ways in which usages of word change, and we have seen, if you kind of look back, the words that were used in a particular way 5 years ago are not used in exact same way now, and so on and so forth. So, this is something very interesting. Okay. So, symbols in a particular language, in some sense you can call that these symbols are referred to as words. Okay. We have in our language so many symbols, we create these symbols out of another set of symbols which are these sounds, and when we create them we also assign some sort of meaning to them. That happens by consensus. There are always people are coining new words, things like selfie. It was not really a word, but somebody started using it in one way and it now becomes a valid word. You might already find it in a few dictionaries. So, this is something which I would expect that you remember, and then let us talk a little bit about, say for some questions that are to be asked when you are working or reading about words. So, what are these questions? So, how do we mentally represent word forms? Where in your head? A lot of students ask me, okay, do we store words at some point or some place in the brain? If we store words at some place in the brain, does, say for example things like one neuron stand for one word? Is it like that? Say for example, I have more than a billion neurons in my head, but I probably know of at least 50,000, 60,000, maybe 1 lakh words. Are 1 lakh neurons really dedicated to storing these 1 lakh words? And if I kind of 1 or 2 of those neurons get damaged, do I lose 1 or 2 of those specific words that were attached to that neuron? These kind of questions can be asked, and this is something which is very interesting. We will probably talk a little bit about this at some point in this chapter. How are these representations organized? How do we represent words in our mind, and how are these representations organized? Are they linked to each other? Are they completely independent? If you pick up one, are you going to pick up others as well, or if you pick up one, you are just picking that one very specifically? how are word meanings represented. Now, okay, a word is one form, but a word has so many meanings, and a word has, say for example, it's a meaning of so many other words. How is this organization coming about? Okay, these are some of the questions that we will answer and ask in this chapter. Other things is, when we hear a word, how do we go about searching for, suppose there is, I say that in area X of your brain all the words are stored, that is all right, but as soon as I say a word Y to you, how do you look for that word Y in that area X of your brain? How do you do it? Also, again, because I am talking of the brain so much, what parts of the brain are involved in storing the words, what parts of the brain are involved in accessing these words? This is also something that we will talk about, okay, and how in the brain these words are accessed, stored, attached to meaning, learned, forgotten, relearned, all of those processes, where are they happening? So, these are some of the very interesting questions that we will try and attempt and answer in this week, and this is basically what I hope that you would have probably understood or got a little idea about by the end of this chapter. So, let us try and begin analyzing what words are. So, if somebody asks me how do you represent words, I would say there are two things at least. One is this concept of form. A word looks like something and a word appears like something if you are talking of the written modality. So, form is what? The phonological code. How does the word sound? That is the phonological representation of a word. Looks like, what are the symbols that represent word? That is one more level here. This part is called the orthographic code. When you write something, the way you write it and the way those alphabets kind of stand for the sound and then the entire word, that is the orthographic code. So, the sound part is the phonological code, the written part is the orthographic code. Okay. This is about form. How do we store these forms in our head? That is one question. The other thing is, after the form is reached or accessed, there is this whole concept of meaning. How do you get the meaning of that word? That is what we want to ask. So, the meaning that the word conveys in form is basically represented in a form of a semantic coding system, a system that probably stores meaning. Let us just keep it at that. Okay. And this coding system probably is linked to a larger system, which is the semantic memory, or let us say the conceptual store. Okay. So, if you have done any psychology, you would know that there is semantic memory, episodic memory, long term memory, short term memory, all of those kind of things. We are probably talking about the semantic memory here. Semantic memory must be the place where these word meanings are organized and stored in a particular manner. Okay. So, this is two levels of looking at how words are represented. One is at the level of the form and the other is at the level of meaning. This is the two kinds of representation I can think about. Now, obviously you have to analyze how words are there. So, let us look at it. The lowest level is at the level of phonetic features. What are the phonetic features? Phonetic features, if you remember, in the last week we were talking about speech, I believe. In the last week we talked about manner of articulation, place of articulation, whether something is voiced or not voiced. This is the lowest level. How are you going to eventually deliver the sounds? This is the phonetic feature level. So, at the lowest level are phonetic features. Say for example, ham and hamster and hamburger are slightly different in terms of the way the sound of am is delivered. Hamster is a shorter one, hamster or hamburger is a different thing. So, this is phonetic features. You combine the phonetic features and you reach what is referred to as the phonemes. Okay. The phonemes can be combined to form bigrams, trigrams. So, phonemes are the basic sounds of the language. Phonetic features is how are you delivering those sounds and articulating and creating those sounds, but the sounds themselves are referred to as phonemes. If you remember, I talked to you about it, that English as a language has around 40 phonemes. So, any kind of versions, all kinds of phonetic features and utterances that one might have can be mapped backwards to these 40 phonemes that English has. Okay. So, that is thing. And obviously, there could be combination of sounds. Say for example, in phonemes you can have bigrams and trigrams. Bigrams is two phonemes put together, trigrams are three phonemes put together, and you can have these kind of arrangements. So, you have phonetic features, you have phonemes. What else? Once you start combining phonemes, you will be led to another level, which is the morpheme. What is the morpheme? Morpheme is the smallest unit in a language that can have a meaning. Smallest meaningful unit of a language is called a morpheme. Okay. Now, morpheme can be an entire word, or there can be a combination of morphemes that make an entire word. So, we have examples of monomorphemic words having one morpheme: cat, dog, rat, bat, all of these are just one morpheme, because this cannot be further broken down. As soon as it is broken down, it reduces into phonemes which are meaningless. Polymorphemic words on the other hand can be broken down, at least one part or both parts will have meaning. Say for example, blackboard is a polymorphemic word, it has two morphemes, black and board, both of them broken down have meanings. In the other hand, you can have word like player, wherein play and at least one of them has a meaning. Play is itself one morpheme, it is called a free morpheme or a lexical morpheme, whereas er is a bound morpheme or a grammatical morpheme. I do not know at what point I will discuss this again, but you need to remember this. So, you have monomorphemic words, you have polymorphemic words. In the polymorphemic words, you can have a free morpheme that can stand alone, has a meaning of its own. You have a bound morpheme that cannot stand alone and does not have a meaning of its own. Okay. So, just redoing this whole analysis part, you have phonetic features, you have phonemes, you have morphemes. This is how you organize this word. Okay. Now, this is a little bit about how you start looking at words. Let us, there is this very interesting conversation, again an image I have taken from Google, but the reference is coming from this very famous book called Alice in Wonderland. A lot of you might have already read it, and Alice in Wonderland, there is this conversation probably between Humpty and Alice, and Humpty is basically, you know, Humpty Dumpty sat on the wall, that guy, you know, that guy is sitting on the wall and Alice is passing by the wall, and she says something, and you know, there is this conversation that ensues. And this is one of the interesting conversations, I always use this in class. And Humpty says something, he says, when I use a word, Humpty said in rather a scornful tone, it means just what I choose it to mean, neither more nor less. Okay. And the question is, says Alice, whether you can make words mean so many different things. I remember this thing is Alice probably refers to Humpty as an egg, and he probably takes offense, and that is where this conversation begins. So, Humpty is saying, when I use a word, it means exactly what I intend it to mean. You know, does that always happen with you as well? If you use a word, does it always exactly mean what you you know, intended it to mean, or people sometimes take it differently? Okay. So, Alice kind of recognizes the fact and says, no, it is possible. So, it is, the question is whether you can make words mean so many different things. Okay. And then to that Humpty retorts, the question actually is, which is to be mastered? What is the exact meaning of the word? Okay. Obviously, there are words with so many different meanings and so many different references and so on, and those words can be kind of, you know, in that sense be used in a variety of ways, but what is it that you intended the word to mean, or what is it that is going to be the dominant meaning of that entire thing? That is the question. Okay. That is one of the basic debates, or the basic and the most important questions you need to understand when you need to understand how word meanings actually function. Okay. So, we will talk about that. This is something we will explore in this section. Okay. This section basically refers to what is called lexical semantics. Lexical just meaning has to do with words in your mental lexicon. Semantics is how the meaning part of this works. So, Jackendorf actually says that there are two aspects to the meaning of a particular word. One is sense, one other is reference. Okay. And he distinguishes between them, and he says sense is the approximate dictionary like entry to a word. Suppose I was showing you this dictionary like entry of the word in the beginning. So, if you look at the dictionary like entry of the word cat, cat is mammal, animal, pet, feline, those kind of things will come in, you know, 4 legs, a tail and whiskers and 2 ears, and all of that will come into that dictionary like entry. However, there is also, you can use a word to refer to something. The word exactly may or may not mean that, but it is used to refer to something. So, you can have a word like catwalk. Okay. What does catwalk mean? It does not necessarily mean a cat's walk. Okay. Catwalk is used to refer to when ladies walk on the ramp in a fashion show and stuff like that. What is it that we are referring to? We are referring to this style of walking which resemble that of a cat's. So, the reference is something there, you know, it refers to the characteristics of the walk. It does not necessarily imply that a cat is walking or that person who is walking there is a cat. it does not imply that. So, the sense part and the reference part are two very important things which we need to have an understanding of, obviously in order to have better and more effective communication. Okay. So, that is small distinction that you should make. Now, another thing is say suppose you look at this very interesting demonstration here. Words can refer to a lot of things, a particular word can refer to so many different. Suppose say for example, you see these two figures here, one is a darker green one and the lighter green one. Suppose I want to refer to this darker, to this square, I can call the square as a few things. I can say give me the darker green object, give me the square, give me the object on the left. You see all these three expressions basically are referring to the same thing. Okay, and that is what a reference typically means. The same thing can be referred to by so many different ways. Okay, and also if you change the world, so this is this example of a two object universe. If there are only two things in this entire universe, one is the figure on the left, one is the figure on the right, I can refer to this figure on the left by saying so many different things. Okay, and you can kind of, in a different universe by the way, if I say give me the one on the left, you will now give me the larger of the two. So, one of the ways I could actually have referred to this is give me the larger of the two shapes. Okay, but if you move to the next slide and the world has changed, now the larger of the two is the circle. Now that reference will not work here. So, for example, this is a good illustration to try and understand how meaning or references of things change when the world changes, when the speaker and the listener change, when the context where the speaker and listener are, that changes. So, this is also I think something very important, and you need to really remember that. Now, moving to meaning, there are various ways in which meaning has been looked at. There are various approaches to meaning that are possible. Okay. One of the approaches to meaning is this whole concept of introspection. This is a very popular, very old concept in psychology, which basically says that you think and you draw conclusions from subjective experience. So, when I talk to you about, let us say, a watch or a pen or an apple or a banana, as soon as you listen to this, you have a subjective experience about this. You know that in my subjective experience, this particular thing like a banana refers to that particular fruit, and that particular fruit tastes in this way, and all of that knowledge comes back. So, whatever you can infer, think, analyze after you have heard this word can all be kind of summed up as being the meaning of this expression banana. That is one way. So, mental representation of meaning might then be analogous to a dictionary, to dictionary like entries, because it will say for example, if I am talking I am analyzing my mental experience of the word banana, it refers to fruit, sweet, yellow in color, slightly yellowish, greenish in color, so on and so forth. All of that kind of is your dictionary like entry. That is one way of doing this. However, words might refer to sometimes types and sometimes tokens. And what is the distinction? When I say animal, animal is a type, bird is a type, okay. But when I say cat or I say sparrow, sparrow is a token of the type bird, cat is a token of the type animal, human being is also a token of the type animal. So, you have to distinguish also between types and tokens. Types are core meanings of words that point to a completely interchangeable set of objects in the world. Okay. So, for example, if you ask me what an animal is, I can give you an example of a cat, rat, dog, anything. But if you ask me examples of what a dog is, I have to kind of talk to you about everything that just is dog. I can kind of go into breeds as well, but that is a different level altogether. Okay. So, individual instances or specific examples of a particular category are referred to as tokens, and that entire category depicted by a particular word is referred to as a type. So, this is something that you have to kind of remember. Now, how do you represent types in your head? How do you kind of store types in your head? So, for example, one of the ways could be that you kind of represent them by their core categories. So, animal could have so many core categories, advocate could have so many categories, student could have so many categories. One of the examples that Traxler takes is bachelor. So, bachelor is what? Human, adult, male, unmarried. Sometimes what however happens is that the core characteristics of each of these categories may not be so discrete from each other. Suppose, say for example, sometimes we always ask this question. I think the biologists will probably be able to give the best answer, but whether a carrot is a vegetable or a fruit, whether a tomato is a vegetable or a fruit, whether a bat is a bird or an animal, those kind of things. So a bachelor, human, adult male, unmarried, but then Pope is also a human, adult male, unmarried. Is it right to refer to the Pope as bachelor, or that's a separate category of itself? Okay, those kind of things. So you will run into problems when you start using this approach of defining core characteristics, and that kind of creates a little bit of a difference. Real words and referred concepts do not always have necessary core or defining. That is another problem. Sometimes real world concepts or real world categories will always have core defining features that separates them from everything else. That is also something that is not very clear, and I said they are not always discrete. They are often fuzzy. Fuzzy basically saying that there might be so many overlapping features with other things. Any feature that you describe of animals and then of birds, some features will kind of overlap, that you have to kind of understand. So this is one way, does not really completely work, but then obviously there could be another ways of looking at how this is there, how you make meaning. So one of the ways is that you can look at meanings as collection of associated concepts. So there might be for one word there might be so many associated concepts, and all of those common associated concepts are, if they are being tied by this word, this is how meaning is organized. Okay. So what very simply can be done is, I give you a word and I basically ask you to tell me everything that comes to mind when I say that word. Suppose when I say cat, tell me everything that comes to mind. I map it in a feature. Then I say dog, and you say everything that comes to mind. Then I say whale, and then I say bat, and then I say, and then whatever features you have made, basically I can tabulate it and I can see which are common features among these things, which are uncommon features among these things, and this is how it kind of can be done. So this is one way of thinking about how meaning can be represented. Okay. In a similar way, semantics, in a similar way, Collins and Loftus and Collins and Quillen imagined that we would be representing meaning, and they said that this whole map that you will make can be referred to as the semantic network. Why semantic? Because this is capturing aspects of meaning, and these aspects of meaning are being captured in this particular network. Why network? Because meanings will have a lot of connected things. Okay. So let us look at the figure a little bit and I will come back to the description. So you see this semantic network, this is an example of a semantic network, and you can see, say for example, that there are so many of these words here. So there is animal, there is fish, there is water, mammal, vertebra, cat, fur. So you have types and tokens, both kinds of things here, and you say for example, there are things that are common. So cat and bear both are mammals, both have fur. Similarly, both are linked to mammal, and mammal are usually falling into the category of vertebrates. So you have vertebra also that is there, that has a vertebra, has this spinal cord. Okay. Whale is, however, as also a mammal. Okay. And but whale lives in water and fish also lives in water, but fish is not connected to mammal directly. So all of this is there. So this is the representation of what is referred to as a semantic network. This entire network is capturing meanings in some sense. Okay, and the meanings are obviously shared between these different types and also shared between different tokens. Okay. So this is what the semantic network is. You see now, just looking at the anatomy of this, each of these words are referred to as nodes. Nodes are particular characteristics, and each of these nodes are linked by some of these arrows which are called links. Links are functional features. So for example, mammal has a vertebra, cat has fur, all of these are links. So cat and fur, what is the link between them? Cat has fur. Cat and mammal, what is the link between them? Cat is a mammal. So you see that this is a semantic network. It has nodes, it has links. The links basically are common, are things that connect between these types and their features, or tokens and their features, either ways. Okay. So nodes represent concepts where meaning in the when the meaning when the network is trying to capture meaning. Links represent the relationship between these particular concepts. So fur as a concept, cat as a concept, mammal as a concept, so on. And then you can also have subordinate and superordinate concepts. So animal is a superordinate concept of mammal, wherein mammal is a subordinate concept of animal. Similarly, you have instances. So cat is a subordinate category from mammal, and even smaller than animal. So this is the connection there. This kind of organization helps conserve some memory resources, because as soon as you are hitting or capturing one aspect, you are already capturing the entire linkage or the entire network. That is something that is happening. So how do you negotiate the network? How does this really work out? If suppose this is the way you storing meaning in your head, Collins and Quillen kind of wanted to test this, and they kind of used something called the priming paradigm. So priming is typically when you hear something and then you hear something later, the relationship between these two things kind of affects how you will react to the second thing. So there is a prime and there is a target, and the prime and target may have a relationship. Depending on the relationship between the prime and target, you can either be faster for the target or slower for the target. Okay, it could be a facilitative priming or it could inhibit something. So what they did was they read out particular kinds of sentences, and the sentences were something like a canary can fly or a canary is a bird. So when they kind of used canary can fly as a prime, they found that people were faster in responding to canary is a bird. They had to simply say yes or no, 2 buttons, yes if it is correct, no if it is wrong. Canary can fly came out, and when they did not register, it comes for a very small duration. Then canary is a bird comes, and then because you already were primed for that, because it can fly it should be a bird kind of thing, you were faster at deciding that canary is a bird. That is how this is happening. They explain this result by describing the flow of activation between the nodes and the links, and they say this is getting faster, or the priming is actually happening because of a concept called spreading activation. What is this concept of spreading activation? It basically says, again, if you look at this network here, if you are activating something like the cat, it also spreads activation, whatever activation is there to cat. Activation basically means here is just that it becomes readily available. So as soon as you see the picture of the cat concept becomes readily available. Now because the cat concept has become readily available, what happens is activation from this concept, this capability of being readily available, this activation flows to everything that is linked to cat. So it flows to fur and it flows to mammal, both of them are close. It probably would flow to vertebra as well in a slightly indirect form of way. It will flow to animal as well in a slightly indirect form of way, and then cat could be attached to so many other things. So everything that is a mammal and has vertebra will also be invariably linked to this. So all of that kind of thing. So as soon as you listen to cat or read the word cat or see the picture of a cat or see a cat, all of this gets activated. This is what spreading activation is like, okay. And then you can ask questions like, okay, why are these words facilitating each other? Because they are linked in one way, okay. So this spreading activation or this facilitation is a hypothetical mental process that takes place when one of the nodes in the semantic network is activated, and that node shares its activity with the other nodes which are linked to this particular node. This spreading activation has 2 properties. It is very fast, it is automatic. This is not something that you can opt out of. As soon as you read the word cat, everything related to that cat in the network will get activated. Also, one of the properties is it diminishes as we go farther away. So cat might have a relative in dog, it might have a relative in tiger, and it might also by virtue of being animal has a relative in an anteater or something like that. But the activations that will probably reach here will probably have diminished beyond being useful. So if the source of activation is this, till here a lot of activation, till here a lot of activation, but when you go much further, the activation has completely faded out. So it is fast, automatic, uncontrollable, and it diminishes as you go further from this. So things that are closer to this concept will get more benefit of this activation, things that are farther off will receive lesser benefit. That is this idea. And people have kind of, I talked to you about priming in that sentence reading kind of thing, but people have used priming in lexical decision tasks as well. A lexical decision task is very simply just you are shown a word and you are asked whether it is a meaningful word or not. Okay. So in classical lexical decision experiments, people respond faster to words like duck if they are preceded by related words like goose, and then if they are preceded by words like horse. So duck, as soon as you read goose, the activation flows to duck and duck is facilitated, but as soon as you reach horse, the activation is not coming to duck, it is probably going to somewhere else, and so reading duck after horse does not really get any benefit. This is called semantic priming by virtue of semantic relationships. There is also something called mediated priming. So if you read, say for example, lion, if you read stripes, it primes lion faster, lion much slower as compared to that it primes tiger. So you have stripes primes tiger, close relationship. Tiger is also anyways related to the lion because they are in the same family, but because lion is tiger is in the middle, lion gets much lesser priming effect. This is called mediated priming, even though it gets some priming anyways. Okay. So one of the ways that the priming paradigm helps us is it helps us evaluate the relationship between objects in the semantic network. At least that is how this particular theory really works. Okay. And people have done a bunch of studies to show this. So Jim Neely did this study in 1977 where some people were told to expect a particular kind of word when they heard a category label. So you could hear body part and then you will hear certain kinds of words, you could hear animal, you could hear certain kind of words. Okay. However, so what happened was the cue was the word body part, and the body part could be followed by actual names of body parts or by birds. Okay, by names of birds. What did they find is that people were not primed for words related to birds like sparrow or feather, etc., but they were primed for words like arm, leg, hand, etc. So because we are kind of more primed with respect to body parts, our own body parts and so on and so forth. Okay, that is one way that this whole priming thing really works. Priming, however, can also result from shared nodes or mere co-occurrence. Say for example, fountain pen or police jail. The police or jail, for example, is still slightly semantically related as well, but fountain and pen are not semantically related at all, but because they are mentioned so many times together, because they co-occur so many times together, they are basically in that sense related to each other. Okay, they get linked, the nodes get shared in the semantic network mainly by co-occurrence. There is a growing consensus that this kind of linkage can be referred to as a separate process as compared to the kind of linkage that was happening between stripes and tiger and lion and those kind of things. So this is referred to as associative priming, the priming that will happen when you say fountain and you say pen, and the other kind will be referred to as semantic priming, and the idea is that semantic priming and associative priming should be different processes because they are kind of building upon different ways of making this connection. So Rhodes and Donaldson, they did this study. They showed subjects pairs of words that were only associatively related, fountain, pen, or semantically related, bread and cereal, or related in both ways. So dog and cat are both mentioned together and they also have semantic relationships. So semantically related or completely unrelated, and they actually found different ERP signatures. ERP is basically the electrical activity that goes on in the brain when you hear something, when you come across a particular stimulus, and they found that for each of these different kinds of relationships there were entirely different kinds of activity happening in the brain, which at least confirmed to us that semantic priming and associative priming are actually different mental processes. Alright, so this is this. Now I was talking about how things are related to each other and how things could get related just by co-occurrence, and people have kind of recognized this and they have kind of tried to build upon this, and what they have come up with is something similar to saying that the terms for things that are frequently connected in experience will also get themselves connected in the mental lexicon. So fountain and pen, they will also get connected in the mental lexicon in a similar manner. Okay, connectivity. Basically when we say connectivity, it basically just reflects how words are associated within a specific network. Say for example, how many words can get connected to this particular target word. Okay, this is connectivity. And how many connections are shared between a set of words. Say for example, fountain and pen and fountain and water are obviously all three of them connected, but what is the strength of connections, what is the manner of connections, what all connections are shared, all of that you also have to keep in mind. High connectivity basically means that a word has so many associates that are connected to each other. Low connectivity means that a word has only very few things connected to each other, and this basically also leads to different kinds of neural responses. So it has been shown that, say for example, high connectivity words that have high connectivity are easier to remember because they are kind of linked to so many things, and any of those many things that they are connected to can act as a cue to remembering them. Okay, that is one way. The words with low connectivity are slightly more difficult to remember because they will probably need a lot of evidence to build up in order to for you to remember them completely. Okay, so the high connectivity, low connectivity, and also it has been shown that they kind of lead to different neural responses in the head. So high connectivity words versus low connectivity words, they will kind of lead to different kinds of neural responses. Counting on this, see what happens in science is you come up with a concept in a particular field, and that concept is also available to everybody doing science, and people can use it in a very different way, or in different using different methods to elaborate the same topic. So this whole concept of associativity is also taken up in fields of machine learning, artificial intelligence, etc., natural language processing, and people there came up with a couple of models of really telling how the words could be arranged in a particular network. And couple of those models we can talk about is the hyperspace analog to language, or the HAL model, or the latent semantic analysis kind of model, which is the this is also another kind of model. Okay, so there are these two models, and both of these models have some things in common. So in both of these models, a word's meaning is determined by the words it occurs with. So for example, if you don't know, if you are don't know the meaning of any word, but you see what words occur around it, you might be able to judge the meaning of this word. That's the whole point. And they say they are kind of counting on the fact that if words are co-occurring together more with each other than with other words, then there should be in some sense a linkage between these two things. So that is also something that these models build upon. Now HL has this it tracks around 70,000 words. It has a big corpus of 200 million words. From that it kind of keeps track of 70,000 words in order to determine the likelihood of co-occurrence of these words in a single utterance. So what is the probability that I have said rat that I am going to say cat as well? Cat and rat, very high probability, versus when I say rat and whether I will say parachute, low probability of co-occurrence. Okay, that kind of thing. The LSA divides its corpus of 5 million words into 30,000 episodes, and they are basically assessed for the number of times each of these 60,000 words appear to. So within that episode, so you have 5 million words corpus, you can divide this into 30,000 episodes, and each of these episodes you have 60,000 words. For each of those 60,000 words you can calculate a number into what is the probability that they would have come together within the episode. Basically what happens here is words get scores depending upon the number and kind of co-occurrences in these episodes, and they are finally represented with a pattern of values. So in LSA you can say that within this episode these are the co-occurrence values of these words. So this word has such a high value, this word has a low value, which basically means so many words co-occur with this or something like that. Okay. Now these approaches basically have they basically help us to capture this concept of associativity or association or co-occurrence, and these kind of models have helped explain some of the priming effects that happen. How do people categorize these words, and how do people judge things like semantic similarity? Okay, so semantic similarity is a function of the number of overlapping semantic features. Words with more common features will have more semantic overlap, words with less common features will have less semantic overlap, and obviously things that have more semantic overlap will be linked stronger together, so it might be easier to prime either of them using the other. Okay, so cat and rat have so many features, cat and fish have so less features, but they are associated because everybody knows that cats like to eat fish, things like that. Okay, so those kind of things are there. Now this is basically all that I wanted to talk to you about. I talked to you a little bit about in this lecture about how meaning could be captured. One was introspection, the other was the semantic networks theory, and the other last one which we are discussing was association. Association can also help in some sense explain some of these priming effects in the semantic networks theory as well as outside of it in these two theories, the HAL and the LSA, which basically says that if you really need to figure out the meaning of the word and you don't know the meaning of the word independently, you can just look at the words around this particular word, and that will already help you get a very good informed guess about the meaning of this word. So, this was a little bit about words and meanings. We will talk to you in the next lecture about, I think, things like lexical access and so on. Thank you.